So we are solving the 13th problem in this series, and the 13th problem in this series is problem number 1.90. The problem is asking a car moves with a constant tangential acceleration at equals 0.62 meter per second square along a horizontal surface circumscribing a circle of radius 40 meter. The coefficient of sliding friction between the wheels of the car and the surface is 0.2. What distance will the car ride without sliding if at the initial moment of time its velocity is equal to 0? So let us first of all understand this problem. It is again a case of non-uniform circular motion, and we are considering this as the horizontal path or the horizontal circular path in which the car is moving. So this is the point where the car starts its motion, that is speed is 0, and as it is moving it is acquiring a certain speed. So if we are discussing at this point P, so the speed which it has attained is equal to V. So at this point A, we can say that there is no radial acceleration because of the absence of velocity, and the radial acceleration is V square upon R. So this tangential component of speed is going to provide for the tangential acceleration, which is already mentioned in the problem. So the speed is increasing because of tangential acceleration, and because of this V, there will be a radial component of acceleration, and both these acceleration will contribute for total acceleration, which must be balanced by the frictional force. The MA must be balanced by the frictional force. So if we start approaching this problem, so we can say that as it covers a displacement S starting from rest, so initial speed is 0, it is having a tangential acceleration at. So after covering a certain distance S, so it will have a speed V square equals U square 2 AS, and we are square rooting this term, so to get this value of V. So we have a tangential component of acceleration which is already mentioned in this problem to be 0.62. So AT being equal to 0.62 meter per second square, and it is moving in a circle of radius 40 meter. So R equals 40 meter, having friction coefficient 0.20. So if we calculate the radial component of acceleration, so radial component of acceleration is V square upon R. So if we calculate V square upon R, so we can say that V square is equal to 2AT multiplied by displacement upon R. So this is the radial component of acceleration that we have, and since both tangential and radial are perpendicular to each other, therefore the net acceleration is vector sum of these two. So AT square plus AR square is square root. So we know all the values except the value of displacement S, which is to be calculated, or the distance S, which is to be calculated. And if we put the value in this term, we get the value for AR equals 0.031 S, and this is 0.62 meter per second square, and therefore on substituting these values we have over here 0.62 square plus 0.031 S square is square root. So this force which will originate because of MA must be balanced by or provided by frictional force. So therefore MA must be equal to the maximum value of friction. So hence we can say that the value of A is equal to mu into G, as the frictional force is equal to mu mg. So if we remove m on both sides, we can equate A equals mu g. So therefore on solving this term, A, which is equal to 0.62 squared plus 0.031 s squared is equal to 0.20 multiplied by 9.8. So on solving this expression we get the value of s as 60 meter. So this is how we approach this problem number 1.90.